Welcome to Vet Zone, where passion for animals, science, and medicine lives.
Hello and welcome back. After the recent loss of my beloved gelding, the topic of secondary toxicosis in wildlife came to mind. Digging a grave in dry, hard ground in December is never fun. Thankfully, my neighbor was kind enough to lend me his backhoe and his dad. He did question why the hole needed to be 8 to 10 foot deep. It was easy for me to switch to veterinary preventive medicine mode and explain the effects of the euthanasia solution on any potential wildlife scavengers. First, let's discuss some of the terms that are commonly used when describing toxins in the environment. One that is frequently used is bioaccumulation. This is the accumulation of a substance, usually toxic, within an organism when the rate of intake of that material is greater than the rate of excretion or metabolic transformation of it. It can be at very low levels and not affect the organism. If the organism continues to accumulate the toxin, eventually harmful levels can be reached. Remember, the dose makes the poison. Biomagnification is the increasing concentration of a toxin in the tissues of organisms at successively higher levels in a food web. Organisms at the top of the food web generally suffer increased harm from a persistent toxin or pollutant than those at lower levels. This is the concept that a toxin in the environment is consumed by plants or animals low in the food web at levels that do not harm these organisms. An example of this is a little fish eats some plankton that is contaminated. The little fish is eaten by a bigger fish that is eaten by a yet bigger fish. Each level of the food web is magnifying the toxin in tissues. The bigger fish is then eaten by a predatory bird. The bird then receives a lethal dose of the toxin. Scary stuff, isn't it? We will start our list of toxins with euthanasia solution. As many of you know, the primary compound is a barbiturate. These drugs have a profound sedative effect on the patient. The drug will be retained in the tissues of the euthanized patient. The problem arises when scavengers, either wildlife or the neighbor's dog, ingest the contaminated tissues. If the scavenger consumes sufficient quantities, the end result will be death. For this reason, I always counsel owners to be sure that the euthanized patient is buried deep enough to prevent scavengers from digging up the remains. Another common group of toxins with secondary effects are rodenticides. There are two classifications, anticoagulants and non-anticoagulants. Anticoagulant rodenticides inhibit the clotting cascade and cause internal hemorrhage. Non-anticoagulant rodenticides can be neurotoxins, vitamin D analogs, or cause hypercalcemia. As with other toxins, ingestion of a rodent that was killed with a rodenticide will result in the death of the scavenger if biomagnification reaches lethal levels. Lead is a concern for waterfowl, upland game birds, birds of prey, and scavenger birds. Lead contamination around lakes, ponds, and rivers can come from fishing tackle, old shotgun pellets, old batteries, or runoff from other sites. Lead shot was banned for use in waterfowl hunting in 1991, but some still remains in the environment. The lead can either be consumed directly by the birds when eating or be a contaminant in the water. It is then bioaccumulated and biomagnified up the food web. Signs of lead poisoning in birds can range from weight loss and emaciation to green-colored feces, weakness, blindness, seizures, and death. Another water contaminant is mercury. It's a potent neurotoxin that affects fish and the birds and mammals that prey on them. Sources include atmospheric deposition or point source discharge. According to the U.S. Environmental Protection Agency, EPA, emissions from coal-fired plants are the largest source of inorganic mercury in the atmosphere. Methylation is the conversion of inorganic mercury into organic methylmercury. This greatly increases the toxicity and accumulation in aquatic life forms. Nearly all of the mercury found in fish tissue is methylmercury. As with other toxins, methylmercury is bioaccumulated low in the food web and biomagnified up the chain. According to the USGS, methylmercury levels in predatory fish are typically more than 1 million times higher than methylmercury levels in water that the fish inhabit. This is just an introduction to the concept of wildlife intoxication, bioaccumulation, and biomagnification. There are numerous substances and compounds in the environment that can have deleterious effects on unintended species. It is our job as stewards of the environment to limit exposure to wildlife to these toxins.